All righty, let's try this again with hopefully less lag on the internet. Hypothesis testing and confidence intervals. There are 6 steps. First, figure out what statistic you want and compute that statistic. It could be the mean, it could be the proportion, difference between means, relative risk, difference between proportions, whatever. Compute your statistic you're interested in, number 1. Number 2, compute the standard error of that statistic. If you remember last time, we talked about the standard error of the mean divided being the standard deviation by the square root of n. Whatever the standard error is for that statistic, compute it. Number 3, obtain a critical value. If you have 30 or more in your sample and you're interested in the 95% confidence interval, then you're going to have a critical value of 1.96. You're going to multiply the standard error by 1.96. If there are fewer people than 30, you're going to look up a t-value for that sample size and the 95% confidence interval. If you have over 30 people, but you want a different confidence interval, say 99%, you're going to look up the z-value for that. And if you want a different alpha level and you have less than 30, you're going to look up the t-value for that. So find the critical value. Usually it's going to be 1.96. Number 4, multiply that critical value that you got in step 3 by the standard error you obtained in step 2. Number 5, subtract the result, the critical value times the standard error, subtract that from the statistic you got in step 1, and that is your lower confidence limit. Add the result, your critical value times standard error, to the statistic you obtained in step 1, and that's your upper confidence limit. So let's go through a problem from your textbook. Problem 6.4. Tells you to do 3 things. Number 1, compute the sample mean. Number 2, compute the sample standard deviation, which you're going to need later. And number 3, construct a 95% confidence interval. Just to review, the mean formula is the sum of all the scores divided by n. So that thing on the left that looks like a sideways W is the Greek letter sigma, stands for sum. X sub I means each individual x. So x sub 1 is the first score, x sub 2 is the second score, and so on. The variance is the sum of x sub I minus the mean squared divided by n minus 1. So all of this was in chapter 4. You're going to compute the variance by taking the difference between the mean and each individual score, squaring that, adding them all up, and dividing by n minus 1. The standard error is the standard deviation divided by the square root of n. And just to remind you, the standard deviation is the square root of the variance. The confidence limit, we just talked about this, is the confidence limits is the statistic minus the critical value times the standard error, and the statistic plus the critical value times the standard error. So we could do this with SAS. We can create a data set by word data and any reasonable data set name. So coffee, semicolon. Remember, always ends in a semicolon. Input, cups. So input is the variables that we're inputting. In this case, we only have one variable, which is the number of cups of coffee they drink every day, semicolon. Data lines, all one word, semicolon, and then the lines of data. And after the last, since we only have one variable, it's one number per line, and a semicolon after the last line of data. Now that we have our data, we could do proc means, mean, STD for standard deviation, and STD-ERR for standard error. And var cups, var is the variable we want the mean, standard deviation, standard error. Now, maybe this isn't the best example because I didn't have a data equals here. The reason is that if you don't have data equals and a data set name, SAS will use the most recently created data set, which in this case is what we want. All right. So we get a mean of 3.25. We get a standard deviation of 2.659 and a standard error of 0.94. You can look up the t-value for the degrees of freedom is 7 because we have 8 people in our sample, and so the degrees of freedom would be 8 minus 1, which is 7, and that t-value is 2.365. So our lower confidence limit is going to be 3.25 minus 2.365 times 0.94. That's our standard error. And that equals 1.03. Our upper confidence limit is going to be 3.25 plus 2.365 times 0.94, and that equals 5.47. So there I did some computation. If I wanted to do no computation at all, I could do the same thing, proc means, and then CLM for confidence limit, mean standard deviation. That would give me everything that was asked in that problem. And again, I need the word bar cups. CLM requests the confidence limit. Alpha equals 0.05 would request the 95% confidence intervals. We didn't really need to put that because that's a default. If you don't give an alpha, that's what it gives you. And amazingly, it gives me exactly what I got when I computed it out. So 1.02 as 6.8, so rounds to 1.03 is the lower limit, 5.47 as upper limit. For relative risk and odds ratio confidence limits with SAS, you could do so this is another problem, 6.7, input the number of people who had their symptoms reduced, a dollar sign. Dollar sign means it's a character variable. The medication, if they had the medication, which is going to be yes or no. So again, that's character variable. So you need a dollar sign after that. And PTS for patients, the number of patients, semicolon. So last time we input only one variable, this time we're inputting 3. Data lines, again, semicolon. And then yes, I put underscore yes here because I want, for this variable, I want this to show up first. If you put an underscore, it'll show up first, as opposed, because it's in alphabetical order. You didn't have to do that, but I did. So I have yes, underscore yes, 38. There were 38 people who had their symptoms reduced and had the medication. No, they did not have the symptoms reduced. Yes, they had the medication. That was 62 people. Yes, they had their symptoms reduced. No, they didn't have the medication, 21 people. And no, 79. So that is how you could enter data if you don't have individual scores, like with the previous example, but you have the number in each group. This 38 is a weight, a number of people who went into yes, they had their symptoms reduced. Yes, they had the medication category. Do proc freq, data equals. This is the data set name that I created up here, called it prob67. Weight, this, if you leave out this weight statement, it's going to assume that the value of patients was 38, not that you had 38 individual patients. It's going to take this as one record. So weight, PTS, could have named anything, but I call it PTS for patient, semicolon, tables, med times reduce / CMH, and this will give you the confidence limits for the odds ratio and relative risk.